Hey, y'all. Welcome to my TED Talk. I'm your host, Peter Pekarchik. I'm originally from Chicago, but have taken shelter in San Antonio, Texas. Do you wonder why? There's about 2 feet of snow on the ground right now, and the weather is like negative 10 degrees. If you don't know much about me, uh, I'm Peter PME on Twitter. I go by Pies, Cars, and Chicks. That's how you pronounce my last name. I'm the co-founder and CTO of DraftBit. DraftBit is a tool that helps teams build mobile apps visually, apps like React Native and Expo. We take care of most of the heavy lifting for you. If you like React Native or Expo, or are trying to learn React Native or Expo, or don't fall into any of those categories, DraftBit is still probably for you. Scan a QR code, you build a screen, and you export your app. This is what it all looks like. And the code that we generate is super high quality senior grade code. Now that we have that out of the way, let's talk GraphQL. Boy, do I have a good story for y'all. If you think you're the only one struggling with GraphQL, this one's for you. Keep in mind, I've been coding for over 10 years and have seen a lot. I started using Macromedia, Flash, and Dreamweaver and still managed to mess this up. I messed this up so royally, they invited me to talk about it, right? A talk called GraphQL Wrong Answers Only. I'm joking about that part, but we did still mess up a lot. And today I'll share some of the things that we messed up about. So when I first started using GraphQL, I came from the REST world, right? So I was thinking in terms of status codes and ways of returning data from the server, right? And so the way that we set up our GraphQL server was a little different. We created a separate resolver for every single query. That is a wrong answer, right? When you think about it that way, you start to build up these queries. You get 10, 20, 30, 40, 100, and you start asking yourself, maybe I'm not doing things correctly. What are people talking about with this n+1 problem? Is it having like n too many queries? Because that's where we were working with. We didn't even have, like a graph to work off of. So you see a lot of stuff like this in the code. Get app by ID. You see this specific query for this specific screen. There was no nesting or getting other data from this, right? This was one top level query. And even if app lived under workspaces, that would be a different query of its own. So you can imagine things weren't going the right way for a little bit. So we sort of readjusted. We learned a little bit about what a field resolver does and how it interacts with your database and how to hook up those fields correctly. And that's when we realized, hey, we should be, using this field resolver, fetching all the information required for that field and moving on, right? And we also learned along the way, for when we were doing all this stuff, with a basic GraphQL server using Connects and Apollo server and plain old GraphQL JS, that we were doing a lot of manual work, and it felt like things could be better, right? So another wrong answer, something that I might have told you 3 or 4 years ago, was write your schema by hand. We quickly learned that there are better ways of doing this. So typically, and I got this directly from the GraphQL website, which is great from a learning perspective and getting started, but you find yourself putting your schema.graphql file in one spot, then your resolvers.js file, which has your JavaScript logic in another spot, and then maybe you'd have all of your resolvers living somewhere else. So you'd have 3 different places to manage that. When you make a mistake in one spot, the other thing will break, right? So if, let's say, I added a new field to our resolver and didn't update the schema, I'd get an error. And you can imagine there was a lot of wasted time doing that. And that's when we discovered something called Prisma Schema. And I think it's called something else, or maybe it doesn't exist anymore. But the beautiful part about it was it was able to consolidate all of that for us and automatically generate the schema on top of providing TypeScript types as well. So as you can see, we use a different function here. It's called extends type, right? We pass in this definition function that lets us set a field. We pass in our user type, which defines all the different fields on a user. And then we just make the request as we normally would. Why is this really nice? Well, our schema file is automatically generated. We have to control this stuff in one spot instead of 3. And it just makes the whole process a lot easier when you've got full TypeScript types for everything. Granted, for some of us, it makes it harder, but I digress. So write once, you get the type safety and an automated schema. It's really nice. Okay, another big thing that we totally messed up when we got the right graph that we needed for GraphQL, right? We had that figured out. We started generating our schema automatically. Guess what happened next? We finally realized what an n+1 problem really was. So some of our users were reporting issues of 4, 5, 10-second load times. We're like, what is going on? Turns out we were fetching up to 40,000 rows per request. I shit you not. I'm a developer of 10 years. I've got an all-star team, and here we are making simple mistakes, probably all my fault. And that's when we discovered data loader, right? So let me explain what I mean by the n+1 problem. So imagine you have a workspaces query, and you've got apps under that. You want to get all the apps for that workspace. Traditionally speaking, for every single workspace, you would create a apps query that would then fetch it over and over again. So if I had 7 workspaces, it would make at least 7 additional the exact same queries to resolve that data, right? And that's what it would look like. And at first glance, this looks totally fine, doesn't it? Right? Get repository, find the thing, and return it, right? All good. Not so much. So what did we do? We started using loaders. So there are tools like Data Loader, and there's a tool like GraphQL Monster. And the beautiful thing about Hasura is they support all of this for you under the hood, which makes it even easier. But for us doing this stuff by hand, we would write a loader that would be called apps by workspace UUID, and it would automatically resolve that information 1 time instead of 7 for every workspace. Okay. Treating your errors differently than your GraphQL payload. Wrong answer. So a lot of the times you would see a query like create app, UUID, name, description, and maybe something along the way broke, right? In GraphQL, you're either going to get a 200 or a 500. 500, your server's down, 200, everything is great. But that doesn't mean that the information in that payload is actually correct. So you have to fumble around with these queries. You have to figure out a way to make it all work. And that's when I discovered a technique I found online where you place error and data at top level. So if error is null, everything is great. But if error exists, you can bubble that up to Apollo, and Apollo will gracefully handle that for you, making the whole process really nice and easy. And now you've got a consistent way of handling error and data top level across your whole app. Now, there are a bunch of different ways of doing this, but I would explore one that works for you, and just keep this in mind because it does make your life a lot easier. Okay, using individual variables instead of input objects. Wrong answer. And let me tell you why. So what I mean by an individual variable is when you've got a mutation like create app, you've got name, description, theme, all required. This is nice, it's very explicit. You can consider this like a JavaScript function that doesn't take an object, right? But now, when you make a change to your query, you have to go update it in a bunch of different places, and you've got a bunch of different divs, right? That could be a little bit of a hassle. So the solution to that is use something like create app input. You set that input object type up above, and when you do change things in the underlying section, you don't have to go through and rewrite a whole bunch of things. This makes it so much easier to iterate on your mutations and make things better. Refetch queries are the future. Wrong answer. You're going in the opposite direction. So at GraphBit, what we would do is we would spend a lot of time writing refetch queries because it was easier for us to use, right? The alternative is to use a cache update. When you're using the Apollo client, updating a query is really easy. But when you're adding or removing, you have to go in there and explicitly say, hey, I'm removing this item from cache, or I'm adding a new one to cache, right? That makes the whole process save you a bunch of requests. When you use refetch queries, for every time you run it, you're making additional requests. Now, when you're running things at scale, that's 2, 3, 4 times the server load than before. Converting a lot of our things over from refetch queries to traditional cache updates made the process so much more seamless and so much faster. And at first, it feels weird to use the cache update, but let me tell you, it makes your life so much easier. All right, everyone. Thank you so much for having me. This was a lightning talk of 10 minutes. I tried to pack it and make it as exciting as I could. Follow me on Twitter, PeterPME. Check out draftbit.com. If you love Hasura and love Expo, DraftBit is a great way for you to hook up the front end of your app to a server. Thanks again for having me, GraphQL Asia. I cannot wait to be able to see you all in person one day when this pandemic is over. All right. Thanks, y'all.